Welcome to doassignment-ca. Here is the problem. The acceleration of a particle traveling along a straight line is a equals 1/4 times the square root of s in meters per second squared, where s is in meters. If v equals 0 and s equals 1 meter when t equals 0, determine the particle's velocity at s equals 2 meters. Now, let us work through the solution step by step. Since acceleration is expressed in terms of position, we use the identity that acceleration equals v times dv ds. This lets us work entirely in terms of position and velocity, with no need to involve time explicitly. We substitute the given acceleration expression into the kinematic identity, giving us v times dv ds equals 1/4 times the square root of s. This is a separable differential equation in v and s. We separate variables to get v dv on the left and 1/4 root s ds on the right. We then integrate both sides, with the lower limit set by the initial condition that v equals 0 when s equals 1 meter. The left integral gives v squared over 2. The right integral gives 1/6 times the quantity s to the 3/2 minus 1. Setting these equal gives our velocity-position relationship. Multiplying both sides by 2 and taking the positive square root gives velocity as a function of position. V equals the square root of 1/3 times the quantity s to the 3/2 minus 1 in meters per second. Substituting s equals 2 meters, we compute 2 to the 3/2, which is 2 times the square root of 2, approximately 2.828. Subtracting 1 gives 1.828, dividing by 3 gives 0.6095, and taking the square root gives approximately 0.781 meters per second. Checking the initial condition. At s equals 1 meter, v equals the square root of 0, which is 0. This matches. The dimensions are also consistent. The exact final answer is v equals the square root of the quantity 2 root 2 minus 1, all divided by 3, which is approximately 0.781 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.